This video will help you simplify square roots and cube roots. So first we're going to find the square root of 192. But before we do that, I'm going to list our square roots or our perfect squares, because that will help us when we are trying to simplify these. So we think of our perfect squares, 1 times 1, obviously 1. 2 squared, 2 times 2 is 4. So if we just keep going, we get 9, 16, 25, 36, 49, 64, 81, 100. I'm going to keep going just a little more. 11 squared, 12 squared. That's probably good for now. So there's two different strategies you can take when we're simplifying square roots. We can look at these perfect squares and try dividing these into this number. So for 192, I'm going to pick something that I'm going to see if it can divide evenly into it. So 192 is a pretty big number, so I might try one of these bigger numbers first, like 64, 81, see if those would split it up evenly. So you can just use Desmos or any calculator. So let's see, divided by 81 does not split evenly, but divided by 64 does. So I'm going to rewrite this as 64 times 3. So then I can also simplify that as the square root of 64 times the square root of 3. Well, the square root of 64, we should recognize that as the square root of 8. But if you're not sure, you can always type it in. If you just type SQRT, it makes the square root, and we can verify that it is 8. So we can simplify this as 8 times the square root of 3. And to check your answer, type this in the calculator and compare it to the square root of 192. So I type in the square root of 192, and then 8 times the square root of 3, and I see I get the same decimal for each, meaning those are equal, meaning I simplified properly. Some of you might have also learned the birthday cake method in Algebra 1. So if you did learn it, you're welcome to use it, but if you didn't learn it, then no worries, it's just another option. So the birthday cake method kind of works backwards. So you start with the number that you're given, 192, and we are going to divide it by the smallest number possible. So I'm going to start by dividing it by 2. When I divide that by 2, I get 96, and I put that on top. So I'm making a layered birthday cake. If I divide 96 by 2, I get 48. And 2 seems to be working for me, so I'm going to keep going with dividing by 2. I get 24. Now I get 12. And now I get 6. And then I can still go one more time. 6 divided by 2, I get 3. So the birthday cake method works by dividing repeatedly until you get to a number at the top that can't be simplified. So it's nice to get a 1, like a birthday candle, but sometimes we might end up with 3, or 2, or any other prime number that can't be simplified. So to figure out our answer for the birthday cake method, we're looking at pairs of numbers. So I see 2 2s, another pair of 2s, and another pair of 2s. So what that's representing is 2 squared 3 different times. So if I were to simplify under my radical, I could have 2 times 2 all of these times, and then I have times 3 at the top. So each of these pairs is going to simplify out, so I have 1 2 times another 2 times another 2 with my square root of 3 left over, and 2 times 2 times 2 is 8. So as we can see, that gives us the same answer, just with a different method. All right, another way to practice simplifying is over here we have a cube root instead of perfect squares. So I'm going to list my perfect cubes first. So my perfect cubes, again, we start with 1, and then we have 8. 3 cubed is 27. 4 cubed is 64. I'm just going to stop at 5 cubed for now. So again, just to show you what all this means. Okay, so I'm going to do the same method of seeing what can divide into 54. So I might need to use Desmos to help me, that's fine. I need to pick one of these smaller numbers, like 8 or 27, because 64 and 125 are just too big. So maybe I try 8, but I get a decimal. So now I'm going to try 27. Awesome. So 27 times 2 equals 54. So I can rewrite this as the cube root of 27 times 2. And that simplifies as the cube root of 27 times the cube root of 2. And the cube root of 27 is just 3. So this is our final answer. And again, you can check that on Desmos or any other calculator. You just need to use the special keyboard down here. And you click functions and then miscellaneous to give you this little n root, and that allows you to type the 3. So we can type the cube root of 54. And then I can also do, let's see, we got, this is our answer. And there we go. We see those decimals are the same, so that means we simplified correctly. Great job.